Hello everyone, today I'm going to introduce the concept of uniform circular motion. So what is uniform circular motion? We can start by looking at some example. In this type of motion, the trajectory forms a circular path. It's called uniform because the magnitude of the velocity remains constant, but the direction is continuously changing. This change in direction is caused by a physical quantity normal acceleration. And to summarize, uniform circular motion occurs when an object travels along a circular path at a constant speed. While the speed stays the same, the direction of motion changes because of centripetal acceleration. And since it's a circle, we represent the radius of the circle as r. So we can say normal acceleration is centripetal acceleration. So let's talk about velocity in uniform circular motion. If we look at the diagram, we can observe that the velocity is always tangential to the circular path, and this is why we refer to it as tangential velocity or tangential speed, which remains constant along the path. However, even though the speed is constant, the direction of the velocity vector keeps changing as the object moves. This change in direction means the velocity vector itself is changing, and we denote this change as delta v. Since acceleration is defined as the change in velocity over a time interval, we can calculate the acceleration. What's interesting here is that this acceleration always points toward the center of circle. So this is the reason why we call it centripetal acceleration. Its formula is centripetal acceleration AC equal to v squared over r, where v is tangential speed and r is the radius of the circle. A quick way to verify this formula is by checking the units. The unit of acceleration is meters per second squared, and tangential velocity has unit of meters per second. Dividing v squared by the radius, and we can obtain the correct unit for acceleration, meter per second squared. So now we already understand centripetal acceleration. Let's move on to centripetal force. According to Newton's second law, the net force is equal to ma. Since the acceleration is centripetal, the centripetal force can be expressed by Fc equal mac. Substituting the formula for centripetal acceleration, we can get centripetal force Fc equal to mv squared over r, where m is the mass of the object, v is the tangential speed, and r is the radius of the circle. Next, let's talk about the concepts of period and frequency. The period is the time it takes for an object to complete one full revolution around the circle. On the other hand, frequency is the number of revolutions completed per unit time. And these two are inversely related, so we can just write this formula: F is 1 over T. So now we understand the definitions and the formulas related to uniform circular motion. Let's talk about some real-life applications. One example is satellites orbiting the Earth. Their motion closely resembles uniform circular motion, where the gravitational force acts as the centripetal force. Another example is cars turning on a circular track. In this case, friction provides the centripetal force needed to keep the car moving along the curve. Lastly, we see this in amusement park rides, such as those that spin in circular paths. These rides also rely on a centripetal force to maintain their motion. Next, let's work with 3 examples to apply what we have learned. Example 1, a ball is fastened to a string and swam in a vertical circle. What if the ball is at the highest point of the circle? What are the directions of its velocity and acceleration? Okay, since the motion is counterclockwise at the highest point, the velocity will be directed to the left, tangential to the circle. Meanwhile, the acceleration always points toward the center of the circle, which in this case is downward. So the answer, the velocity is turned to the left and the acceleration is downward. A 0.2 kilogram ball rotates at a constant speed of 3 meters per second on the end of 1.2 meter long string, forming a horizontal circle. And the problem is, what is the centripetal acceleration? So using the formula for centripetal acceleration, AC is V squared over R. We substitute V is 3 and R is 1.2 meters. Calculating, we can get this formula will be 3 squared over 1.2, and the answer will be 7.5 meters per second squared. And example 3, a centripetal force is applied to an eraser moving at a constant speed v in the horizontal circle of radius r. If the same force is applied but the radius is halved, what happens to the speed of the eraser? Okay, initially, the centripetal force is mv squared over r. After the radius is halved, so we can get the new force is mu squared over 0.5 r, or you can just say half r. And u is the new velocity. So setting the original force equal to new force. So we can write down the mu squared over half r equal to here, equal to mv squared over r. So with simplifying, we can obtain the u squared is 0.5 v squared. So we can get u is v over the square root of 2. So that means the new velocity is reduced by a factor of square root of 2. So the answer will be D. Okay, the answer will be D. So this is the course we have today, and I hope you can learn something. See you.